Hi everyone, welcome to our first YouTube channel on coding with C++. So today we'll be having our first lesson, which will be introduction to C++. And introduction with C++ comes with the basic concept of C++, all the basic things that are involved. In this lesson, you will be introduced to C++. You learn the difference between C and C++. You learn the basic concepts as I said earlier. You understand the C++ program, its development process, the difference between the process and threads, and you explore the C++ programming in code blocks. So meaning code blocks should be the software you'll be using. So C++ was created by Bijan Struff in 1979. It was initially known as C with classes, but later it was coined by Rick Massity in 1983, and C++ evolved from C. So which means we can say something like C is the mother to C++. So in the mid-1998, ANSI and ISO C++ language standards were approved. ANSI and ISO are non-governmental organizations or bodies that they implement standards, or they have standards that programming languages should meet. So C++ was designed to implement OOD, and OOD simply means object-oriented design. C++ is a compiled language, unlike other languages where we have machine languages and among the others. Similarly, C++ is also a compiled language, which means C++ uses a compiler, and C++ is a universally usable modular program. With this, so as a modular program simply means C++ is made up of self-contained parts, and these parts handle specific job, which at the end of the day they all work together. As I said, so the C++ has a compiler, it has a debugging tool. All these form parts of the contained parts which come together to perform the job, which is a programming. So with coming to think of it, the C++, its modularity is enabled through a whole lot of key features such as the header and source file, the namespaces, the classes and object, the templates, the standard libraries, and others. So we'll be moving towards them. So we come to object-oriented programming. With object-oriented programming, OOP, it identifies components called objects. These objects combines data and operations on the data into a single unit. The primary goal of OOP is to increase the flexibility and maintainability of programs, especially large and complex ones. So with the object-oriented programming, we have data, which are the attributes, and we have functions, which are the methods. And these attributes, they are more about what the object has or knows, whereas the functions is what the object can do. So a programming language that implements object-oriented design, OOD, is called an object-oriented programming language. Now we are going to the principles of object-oriented programming. We have data abstraction, and these principles will later be dealt with furthermore when we go ahead. So data abstraction, that is the creation of classes to describe objects, and data encapsulation is for controlled access to data, to object data. So with this, the encapsulation, it restricts access to internal data objects and exposing the only necessary parts. When it comes to the inheritance also, it creates derived classes including multiple derived classes. The polymorphism, which is the Greek word for multiform, that is the implementation of instruction. With a polymorphism, objects can take on many forms, allowing the same interface to behave differently. And there is more flexibility and extensibility when it comes to the polymorphism aspect. And also the polymorphism we use to override methods and virtual functions. So now we come to processing a C++ program. So to process a C++ program, you execute the program. And C++ is a high-level language program, and we have to keep that in mind. So with high-level languages programs, you use an editor to create a source program. After your editor, you come to the C++ program statement, which begins with the symbol, the hashtag. The hash. Yeah. So with the hash, we can have user created. So in a basic C++ program, the hash is known as the preprocessor directives, and this tells the compiler to include the IOStream or the iStream or the OStream library before compiling. So it depends on what you add, the statement you add to your preprocessor. So you can add maybe hash include less than, greater than, then you put your IOStream or iStream or OStream. Then we have user defined also directives. You have user defined directives also. So these statements are processed by a program called preprocessor, as I made mention of. You use the compiler to 1, check that the program obeys the rules, and 2, translate into machine language. That's the object program. So since the machine only understands its language is the machine language, but the C++ is a high-level language, meaning the C++ needs something like a mediator or like an intermediary that will help it to transform from the high-level language to the machine language. So that is the use of the compiler. The compiler will process the high-level language to the machine language. Yeah. When you do some research should tell you that from high-level language, it comes to assembly language before it gets the machine language. Others too will not tell you that. Other researchers will tell you from high-level language, it's just that some skirmishes, then comes to the machine language, which is not really possible. So now we come to software development kit. That's the SDK. It is used to create the program. That's what we use to create our program. Then we have our linker, which combines the object program with other programs provided by the SDK to create executable codes. So with the linker, it gathers compiled versions of multiple source files and fuses them into one program. Yeah, so that's why it is written that the linker combines object programs with other programs provided by the SDK, and it also connects to libraries. So this is a pictorial or a visual representation of a clear C++ program from the editor through to the very last stage. Yeah. So from your step, we have steps from the editor to your very last stage, and they follow the steps. Now we come to our compiling and linking. When you run your code through the compiler, and if the compiler is being processed or as the compiler is running, it checks errors, and as a programmer, you should be able to correct the errors from your code, and that also makes you a programmer. A programmer is not only writing code. You have to learn how to correct these codes, and through that you build your journey very well. And if there are no errors in your codes, the compiler generates equivalent machine code. So as I said, the compiler is the intermediary now. So it generates from the high level language, then it comes to the machine code. So the linker links the code you've written to the system resources. So now loading and executing, the program transitions from being just a file on a disk to becoming an active process, and the final step is to execute the program. So one thing we should notice is the compiler guarantees that the program follows the rules of the language, but does not guarantee that the program will run correctly. So which means that it is not the compiler's duty to guarantee that your program will run correctly or not, but the compiler will guarantee that the program will follow all the rules of the language. Now we'll go to process. Process is a program loaded into the memory alongside all the resources needed by the program. Each running instance of a program is a process. Each process runs independently. Threads. A thread is a unit of execution within a process. Multiple threads can be initiated from a single process. There are single-threaded processes and multiple-threaded processes. So this is a visual representation of the process and thread. So we can see that process is somewhat like parents, whilst threads are like the children. Like simple understanding. So threads and processes in programming. We have the program starts out as a test file or program code. The program is compiled or interpreted into binary form. The program is loaded into memory. So we all know the machine language we have been talking about is just zeros and ones. That is the only language the computer understands. So all the typing and testing you've been doing, it changes to zeros and ones for the machine to understand, and your feedback is given. So with the program becomes one or more running processes. Processes are typically independent of one another. Threads exist as a subset of a process, as I was using the parent-child explanation. Threads can communicate with each other more easily than processes can. Since the processes are different, let's take it that if in the family is an extended family, your aunt and your mom, though they are siblings, but they can't really communicate like how you and your cousins, like you and your siblings, might communicate. Because of a whole lot. So this is now our working space, and that is our preprocessor directive. The hash include IO stream. That is our preprocessor directives. So over here, you can see that you can choose to change it to fit your choice. That's why I said earlier, we have user defined, then we have system defined. So now we come down to do some small programming. And as you know, building your programming, you must not start with a haste. You have to learn the basics first. If you're able to get the basics, trust me, everything is going to be very smooth for you. And I wish everybody, including myself, the best in our journey as a either computer science student or as a programmer, a beginner, a pro, or a yet to start, let me say a newbie. So wishing everybody the best in their journeys. See you all soon, and do not forget to like, subscribe, and share. And in case you think I didn't make an explanation very clear to you, you can just comment it in the comment section, and I'll come and address it to you. And if you have any questions, you also drop them in the comment section as well. When I come, I'll make sure I read your questions and give you your answers as desired. Don't forget to stay tuned to this channel because there are more to unfold. See you all soon. Bye.